So, hi everyone, good morning all. I hope you guys are doing great and it's Sunday. So, if I'm audible, very much audible enough, just let me know here in the chat window so that we can start this wonderful journey today. Right, so anyway, morning all. I'm audible, very much wonderful. So verify the same, Piyush, when 25 are visible and 40 are there. So verify from the chat list or the way you want. Wonderful. So anyway, so how many of you have done this assignment that I've shared yesterday? Just type done message. I just really want to understand. Ansible task done. So whosoever have done the same, you can type done message in the chat window. Alright, great. I haven't checked yet, but I'll be doing it today. Okay. Yeah, Tendulkar, you are very busy actually. We'll do first the session. Alright. It's a lot of people. Great. So anyway, whosoever have done, that is really wonderful. So it's really awesome. I mean, running containers inside container is very awesome thing. Anyway, now what I'm going to do, I'm going to talk about today. Let's just summarize first of all. So actually we started our journey with Linux. Few sessions of Linux we had, then we directly moved to Docker, and in Docker we have done a lot of things, right? Then we moved to Git and Jenkins. Although in Jenkins we have to do few more things, and then we move to Ansible, and now we are very close to start Kubernetes. Okay, trust me, Ansible is very bit just added version, that's it, right? So this is what, and if you really combine all these technologies in a very much advanced way, you can be a DevOps engineer in IT industry. Okay, so this is not that much small, but the knowledge of Docker and Kubernetes along with Jenkins, a few knowledge of Ansible, and we all are doing on top of AWS, right? So that is something you can now whenever you have free time, just ask me for more assignments regarding the same, because once you get the assignment you will be able to handle that everything. So I have couple of videos on assignments also, and couple of videos need to be published publicly, but yes, you can think about that. All right, so today we are going to talk about containerized application deployment. That means containerized application deployment, right, in real world. So exactly how people are deploying their containerized application in real world. Okay, so there is a lot of difference when I say in real world, when I say in Amazon cloud, when I say in Docker. It is very much different things. So as of now, let's say if you are a developer, so what we are doing till now, if we are a developer, we have code, and the code got integrated with Docker file, and then we get new Docker image, right? So I think it's very easy to understand now. You have code, you just have written Docker file, and by this build process, right, by this build process you can just deploy Docker image. When the Docker image got deployed, got created, you can push this image to any of the Docker registry. Okay, although we only understand or know about Docker Hub, but like Docker Hub, there are so many registries we can push that image over there. Okay, when we push this image on any of the registry like Docker Hub or any other places, so this image is now publicly available. Okay, that means this is the some kind of journey, or I can say here, now this image is available to use. Okay, now if it is available to use, definitely this was a developer system. Okay, developer system or PC or laptop. Now this image you can deploy anywhere, right? Let's say you have another server where Docker engine is running. Okay, you have another PC where Docker engine is running, or you have any cloud based server where Docker engine is running. Anywhere you want to deploy this or this. So that means if you have a normal company, you would have a server, you can deploy it on PC, on cloud based server. Okay, anywhere you can deploy it. When I say deploy, it means you are going to do that web application live for real world, so people can use like Google, Facebook or other websites. That's process of deployment. Okay, now things need to be taken care during the application deployment. Things need to be taken care, and these are very important things. First one is security, right? If you're deploying your application like somewhere in any of the environment like server or PCs or cloud environment, the first and major concern for a application developer or for that company is security. If your application is not secure, then the data inside that will be leaked, and in short it may be hacked by any of the developer or hacker or whosoever have the right knowledge. The second most important thing is downtime. Okay, even downtime I can put it to number one. Second, I can say security. Downtime means how this web application is not getting down due to any fact or any reason. So for example, if I want to show you an example of downtime, in RTU in general, when the exam results are announced, your website is not behaving very well. Okay, that means whenever there are so many number of users are coming to access that website, the website is not behaving well. It is getting slow, sometimes it is not available, we are not able to see the results. So if there are so many users, you have to make sure the website is running as smooth as it was. That's what downtime must be leading to zero, either almost zero or leading to zero. You can think about google.com or facebook.com. So the big word, most reliable website is google.com, that is almost having zero downtime. although you know that how many users are accessing google.com in a day, in a second, in a microsecond, still Google has the same behavior. Okay, so downtime is the major concern for Google or other big companies. Even for maintaining that reliability of site google.com, Google has created a new engineering department, and that is really awesome. That is site reliability engineer. Maybe I'll be giving some ideas about SRE engineers later on, not right now but later on. But the concern is, the purpose of this one is to maintain that website, so this website must not be down, okay, must not be unavailable. Okay, so if you are understanding point number 1, point number 2, just say yes in the chat window, right? Say yes in the chat window very quickly. I can just talk about next component that things need to be taken care. So for Harshvardhan, it's yes. I hope downtime must be very much understood, right? I'm only getting messages. Harsh, Sonu, Manan, alright, Neha and Radham. Okay, wonderful. So as of now, downtime is very important factor. The third factor is upgradation. If you are upgrading your application, it must not also getting down, or without any problem we must be able to upgrade our application. So let's say we have version 1, version 2, version 3 of the application. So the process must be very much smooth, very much easy to upgrade your web application simply, right? The next thing is portability, right? So that means portability means if your website is running initially in the server for 1 year, and due to some reason you think that this server is not that much enough to handle the traffic, so as a DevOps engineer or as an administrator, your boss is asking to migrate this website from this normal server to cloud server. Okay, so that means if you are migrating it from here to somewhere else, this application must be very much portable, so that you can take that code and you can deploy it somewhere else. So that means the portability must be in the web code. So the code must be designed in such a way so it can be portable, and portability comes with migration feature. So migration means easy to shift. Okay, easy to shift. That means there must be the process must not be that much complex to migrate your entire web server from here to cloud environment. Okay, so portability always comes with respect to the code, but migration comes to the entire web server. So your web server can be migrated to somewhere else. So that is what the difference between portability and migration is. Okay, now the next one is auto scaling. This is the most important feature that your platform must have, auto scaling, right? So auto scaling means on demand number of web server must be increased. So about this point I'll be talking about this later on, all right? So that will be something. Okay, so if you are understanding it well, then just type yes in the chat window, right? So right? Alright, so I hope you guys are understanding it very well without any problem. Alright, great. So auto scaling is again very important feature. And the final one, either we have a huge bucket here, but I'm just showing you some most important features of a web application deployment, and that is fast or super fast deployment. Fine. So that means the deployment process can have these many facilities or options, but it will be great if it has super fast deployment process. So that means it must not be that much complex to deploy, and that must not be that much time taken as well, right? So I hope these all points will be very much obvious. So you know what, these are the best examples in your interviews if you really want to impress your interviewer, and if you are saying these words: security, downtime, upgradation, portability, migration, auto scaling, fast deployment, the person will be really very happy. Okay, so we have so many options. Let's say this, but as of now, everything we want to achieve when we have a containerized application. That means my application is inbuilt or coded with the Docker image. So if we have Docker image, then we need to use that Docker platform deployment, right? So to achieve all these functionalities, we need a proper server setup, right? We need a proper server setup. That means very proper. Let's say if I want to achieve all these factors, I'm calling it FAC factors, right? We have to think about it. So for example, if you are a cloud engineer, right? You are a cloud engineer and you deployed one EC2 server on Amazon cloud, then you install Docker here, and your Docker image along with the code is here, and you are going to create a container on top of it, because Amazon cloud is very secure, very fast, so your application will be running. Okay, your application will be running almost forever. So that means if you are having this Docker image and then you are launching an EC2 instance on the Amazon cloud, let's say this is you are doing on AWS cloud, and then you are having Docker here, and from this Docker you created this container, and now your web app is running. Okay, web app is running. According to you, this is your real application. According to you, which one is the most difficult thing to achieve out of the bucket list? Right? Which one is most difficult to achieve in the earlier setup that I'm showing you here? If you are doing this, then out of the bucket list, which one is the most difficult thing to achieve out of the list? So you can give one answer each, right? According to you, what is the most difficult thing in terms of your web application? So Rhythm saying is upgrade. What about others? Right, you don't have to worry about things. Migration, auto scaling, maybe, and other people, downtime, super fast deployment, downtime, auto scaling, and security, fast deployment is even not in the list. fast deployment. Okay, cool. Downtime. Okay, fine. So a lot of answers, maximum answers are illogical. That means you're not thinking about them, and everything is fine. Okay, so the most critical or most unachievable things in this particular setup is downtime, right? Rest everything can be achieved except downtime, right? I'm not saying that much in very easy way, but yes, everything except downtime can be achieved, right? And why downtime cannot be maintained? See, we have very huge server as a EC2 instance, a lot of CPU and RAM and so many things, right? And your Docker engine is running and your container is also running. We don't have lack of networking resources or something, but in by any chance, if this server goes off, let's say electricity of this server or internet connection or any bug got tracked or you hacked it or this got rebooted or this got shut off, if it happens, I'm saying if, by any reason, right? If it happens, so Docker engine will be stopped and Docker container will be stopped. Your website is not running anymore, right? So even you have so many huge resources here, so much huge resources here, still web application will be down. All right, and so that we have to plan in such a way, right? So if we are worried about a single EC2 instance, or I can say single server is not enough in terms of downtime, what I can do, I can have 2 EC2 servers, right? I'm not saying it's the only one, but here is something that you have to maintain. So I'm taking 1 server, 2 server, let's say 3 server, 4 and many more like this. And what we did, because there was a chance of a single server, so we are installing Docker engine everywhere. We are installing Docker engine everywhere. Okay, now you are a Docker engineer sitting here in your laptop, so you are a Docker engineer. Very good, you are a Docker engineer. Now you have so many servers, so that means even if the electricity or due to any reason this server goes off, these are still there. So let's say if I am giving a single application to you, you converted that application into Docker image. Now what you do as an administrator, you just download this image somewhere. Let's say you're deploying this Docker image to this machine and the container is running. Okay, you still have so many access of servers. If the container is running and there is no problem, what if this goes down? You can write some script or some process to take this container or take this Docker image and deploy a new container here from the same image. If this server goes down, you have a script that will keep checking it and it will deploy or select another machine and deploy the container. You know that from a Docker image to create container, it is not taking more than 1 to 5 second time. So it's okay if it is getting down for 2 seconds as a human, right? If it is okay if it is getting down for 2 seconds or 3 seconds or so. Okay, and if something happen, it is going to, you can use this server or you can maintain that one again. So rather than dependent on a single server, you can have so many servers and then you can keep switching your application in the next one because you have written some script. Maybe you can use here Ansible. to deploy container on the target machine. Okay, so first of all you have to learn Ansible and you have to deploy it somewhere, right? Now assume that as of now you are having only one Docker image and you are writing Ansible script for one Docker application, container. For example, let's say you have 10,000 Docker images for 10,000 different customers, and now you have to manage these 10,000 Docker images to deploy 10,000 containers across different nodes. Let's say 2,000 containers are here, 1,000 are here, 3,000 are here, and so on. So what you have to do as an engineer, because you know what, in the real world environment, if you are purchasing that much costly servers, definitely you are not going to host only a single application. You're going to host so many applications for business purpose. So 10,000 application and some of application running here, there, and so many buzzing things are there, right? Now if 10 customers are saying their website is not working, then you have to figure out of this 10,000 which Docker image of this customer is, and you need to call your Ansible. Yes, now this customer is buzzing me. Run those 10 playbooks and check if this container is not available, deploy it somewhere else. Don't you think how the big asshole management is here, right? That means you are going to be crazy, right? Because 10,000 Docker images and so many containers are running here and there, remembering them which customer website is running in which Docker engine, which one is down, just take them out and put it over there, remember that in somewhere Excel sheet, and keep maintaining that, and you'll be like, shit, fucked up, oh my god, right? If you're understanding that situation, management of container is a big problem. Management of container is big problem, right? If you are understanding it very well, this situation, see, right now we have 4 servers. Let's assume it, we in real world we have 10,000 servers. We have 1,000 servers, 100 servers, and each server running 1,000 of containers. You have to remember which server running which container, and this is for which customer particularly. Okay, so type yes, okay, fine, understood message in the chat window if you are understanding it very well. Okay, I think my streaming is not down, is it? Internet is working, right? So hello, hi, okay, yes. So if you are understanding it very well, just type yes, okay, cool, fine, bingo, whatever message you want. But this is really important, that this problem is really very big. All right, great. All right, so it is really very understood, very much obvious. When you have so many applications, it is really very impossible to manage and remember all those things. All right, now if I'll go back here, wonderful. If I'll go back here, so this kind of situation in the world of containerization, we need to solve it. Okay, so if we have this kind of situation in the container, so we need something that can automatically perform all these things for you without worrying about anything. It can automatically decide, okay, which customer website is not working. It will automatically solve that problem. As a human, you don't have to make an interruption over there, right? So this kind of thing, we call it, in reality we are calling it container orchestration. So that means managing those container, maintaining it, upgrading, and making database and so many things is known as container orchestration. So we need some container orchestration tool that can solve this problem for us. So these container orchestration tools are number of tools in the market. So the first one is Docker Swarm. Okay, so Docker has its own tool called Docker Swarm, and that is awesome, actually very awesome tool. Then there was one more tool that is not being used these days, Doku. You can use Apache Mesos, right, and many more, or you can use Kubernetes as well. So Docker Swarm, Doku, Apache Mesos, and Kubernetes. There is a huge list, right? Huge list. So the word most powerful and most popular container orchestration tools, or I cannot say tools, technology, right? The most popular one is Kubernetes. I can say most popular, most powerful, most amazing, you name it. Any feature in Kubernetes is the awesome product, right? So Kubernetes is the awesome product, right, ever. So actually Kubernetes is my crush. I've never seen such an interesting technology till now, and I'm in love with Kubernetes, right? So, and if you practice it for every day, you know what, you're going to love it too, definitely, right? So Kubernetes is the next generation container orchestration engine. So definitely we are going to talk about Kubernetes, and Kubernetes is also known as K8S because we have 8 characters between K and S. So Kubernetes is also known as K8S, right? So Kubernetes is the next generation, right? Next generation container orchestration engine. Container orchestration engine, right? So for Kubernetes, let's say hurrah. So you can type hurrah in the chat window just for to show your gratitude or happiness, because we are going to learn the most amazing technology ever, that is Kubernetes, right? So I'm expecting messages from everyone, and make sure whosoever have joined today, only these people will be able to attend these sessions from now onwards, right? So I'll be making this private channel, private video. Great. So waiting for a response from everyone. Great, wonderful. I like this energy anyway. Fine. So now Kubernetes is originally, and I'm just calling it K8S for now. So K8S is originally designed by Google, right? So Kubernetes originally designed by Google, and Google has written in Go programming language. So the most amazing example of Go product is Kubernetes. So entire Kubernetes is designed in Go language, right? And you know what, this is the most recent technology even. So I think in 2015 Kubernetes came in IT industry. I need to check it, but I guess it's 2015. So Kubernetes, yes, 2014 it was, 7 June 2014, 5 years back, right? So right, great, Piyush. So and it is written in Golang, right? Initially designed by Google. Now Google has donated this product to a company called CNCF. Now CNCF is these days maintaining Kubernetes, and it's pure open source project, right? So Cloud Native Computing Foundation is the company as of now that is maintaining Kubernetes these days, but it was originally designed by Google, right? See, originally designed by Google, but now maintained by Cloud Native Computing Foundation. And it's just 5-year-old technology. And don't trust me, just Google it about Kubernetes. Is the most popular and amazing product ever, right? So definitely when Google has so much time, and they have contributed really very hard. So for Golang developers it's really amazing. Yeah, that has no worries. So anyway, so first of all you have to understand how Kubernetes is going to solve this problem that we have introduced here. Okay, so first of all you have to understand Kubernetes architecture. So first of all we are going to talk about Kubernetes architecture. Okay, so that means Kubernetes architecture, if you understood the Kubernetes architecture, you will be actually able to understand the power of Kubernetes, how awesome and how amazing it is, right? So as of now, let's say to deploy your Kubernetes architecture in any of the environment, now it can be deployed anywhere. So first of all you need a server, and this server cannot be anything except Linux based. So this server must be Linux based. Okay, and we need another server, another server, another server. These also must be Linux based. This machine can be Windows, but only Windows 2019 server, not accept that. So only Windows 2019 can be, we can use for our own purpose. Now everything is connected to a networking switch. So that means now this main system is connected to this networking device, and this device having connection to this. Okay, so at least this is the minimum or the most simplest thing you need to understand in Kubernetes. All right, so that means in Kubernetes architecture this will be calling as a Kubernetes master, and these machines we are calling as Kubernetes minions. Okay, so minion 1, minion 2 and minion 3. So the main system, this one, will be calling as a Kubernetes master, and these machines will be calling as Kubernetes minions. And in some cases, right, in some cases we are also calling them worker. So either you call them minion or worker, but the right or correct name is minion, right? So we have three minion: minion 1, minion 2, and minion 3, and this is my master machine, and they all are connected through networking, so they all four can communicate to each other. Now, to deploy Kubernetes setup, right, what you need to do, you need to install Docker in every machine, right, here also and here also. So in master and minion both, you need to deploy what I say Kubernetes, sorry, Docker in every machine, right? So hopefully you are also understanding we need to install Docker. Why we need to install Docker, that point I'll be telling you. Okay, let me tell you, because you know what, Kubernetes can not create containers. So Kubernetes is not for creating containers, Kubernetes is for managing containers. So if you see here on the above, this is orchestration tool, container orchestration tool, and here Docker has created those containers. So the container created by Docker or any other product, it will be managed by Kubernetes. So that's why we need Docker everywhere, or if not Docker, any container technology. Let's say we can also use Podman, we can also use Cryo, whatever technology, container D, and many more. So I hope if you are understanding it, we don't need only Docker, any product like Docker, Podman, something. So say yes in the chat window if you are understanding. Kubernetes is not for creating containers, Kubernetes is for maintaining containers, managing, auto scaling, security, and a lot of things. So that's why we need Docker everywhere, or any of the container runtime technology. So if you are understanding it, just say yes in the chat window. All set. Wonderful. So now if this is your Kubernetes setup, so first of all, as we discussed in the above checklist, this checklist, you know what, each and everything, every single feature, facility is offered by Kubernetes, right? So whatever expectations were there in the above list, every single thing is offered by Kubernetes. Now the point is how Kubernetes is going to achieve all these functionalities for you, right? Because you know what, you need to understand entire thing in very much detail, then you can think about Kubernetes in reality. Okay, so what I need to do, I need to redesign that architecture. So this is my Kubernetes master machine, and let's say this is my minion 1 and minion 2, minion 1 and minion 2, and they all are connected, I'm assuming that. Okay, Docker engine is running everywhere. So now what we need to do is we need to understand how Kubernetes is managing all this. Okay, so entire Kubernetes is a collection of so many products. You know what, so the most important component in Kubernetes master node is we have Kube API server, right? Kube API server. That means the achievement or the list of achievement that we had above, how Kubernetes will achieve that. So it's not about master and worker minion only. Kubernetes nodes has so many components. So those components are responsible for maintaining and achieving those things that we are expecting as of now. So you know what, the most important and most amazing component in the master node only is Kube API server. Now in a very much descriptive way, you have to understand what exactly Kube API server is. So let's say if this is administrator or this is a developer, fine. So either you are an administrator or developer. How any of the client or developer can access to Kubernetes cluster? So I'm calling it this entire setup as a Kubernetes cluster. Okay, so how you and me can connect to Kubernetes cluster? It's very much same way like from our own laptop, how we were connected to Docker engine that was running on top of EC2. So the answer was we are connecting to Docker engine by TCP socket. I hope you remember that fact. So we have exported that variable called export docker host and something docker host, then we connecting to Docker engine and we are maintaining it. So we don't need to get access of it, we can connect it by TCP socket. If you did remember that, just say yes in the chat window, because it is very important to relate the technology that we have learned earlier, right? So say yes, okay, hi, hello, whatever you want, feel like. Okay, wonderful. For Sonu, it's yes, you remember that. So the way we were connecting to remote Docker engine was this, right? Okay, great. So I was expecting the same. Now likewise here we have TCP socket. So to access your Kubernetes cluster, we can connect to Kubernetes API server. So Kubernetes API server, so any user or developer, they can connect to Kube API server. So that is kind of endpoint. So endpoint means where either you and me can connect to Kube API server for any further communications. Let's say if I have a Docker image and I want to deploy it in Kubernetes cluster, so I can never go in minion node and deploy container. I just need to connect to Kube API server and ask that yes, I want to deploy this. So if you want to delete any container, you want to do anything regarding deployment or management or something, the only point of contact for you is Kube API server, right? And this Kube API server is running on master node only. Fine. So the Kube API server is running on the master node only, nothing else. I mean, except master node, it is not running anywhere, right? So I hope you all are understanding that the use of Kube API server. Why my laptop battery is dead, right? So hopefully you are understanding it. So are you able to hear me? Because I can feel in my mobile phone the streaming is not up. You can hear me? Yes or no? Okay, great. So I think you screen is frozen. Okay, but you are able to see that. Okay, so now Kube API server is very much okay as of now. The next one is another component in Kubernetes. We call it Kube Scheduler. That means if as a developer or as administrator I requested for my Kube API server that yes, I really want to deploy my Docker image in Kubernetes cluster itself, so which will be received by Kube API server, but how Kubernetes master will decide out of the list of minion nodes where exactly this container will be deployed. So first of all, you have to understand very well that Kubernetes master will never deploy your container in its own node. So here your container will not be deployed, it is just a management node. So in any of the minion, either minion 1 or minion 2, this will be deployed, right? So either in minion 1 or minion 2 or whatever minions you have, this will be deployed. So now out of the list of minions, which minion will be the one where your container will be deployed? So this decision will be taken care by Kube Scheduler, right? So Kube Scheduler is that component, right? So that you can use to schedule any of the application in any worker node like this or this. Thank you so much Tendulkar for reminding me. Charger kharab ho gaya. I cannot help myself in this quarantine, right? But chal raha hai abhi, theek hai. Okay, so you are understanding Kube Scheduler. So Kube Scheduler will do something like that. It will find the right worker node or minion node, then it will deploy container here. Okay, so that means the use of Kube Scheduler must be very much understood. So this Kube Scheduler will take the responsibility of selecting the right minion node for you, and then it will schedule container in any of the minion node. So that is the use of Kube Scheduler as of now. Okay, but how Kube Scheduler will understand which minion is healthy, which minion is very much okay, and it's, healthy means it has enough resources. So we have another component in master node, we are calling it node controller, right? Okay, so now node controller is the one that will take the responsibility to check the health of minion nodes. That means, is this minion is very much healthy, it has enough resources, or maybe you want to add a new minion on the real time, right? It was a new minion in the real time, so it can add a new minion in the Kubernetes cluster. And if something you want to disconnect, so you want to put it down for some reason, let's say for maintenance, for backup purpose, you want to remove that node, so this responsibility will also be taken care by node controller. Okay, so if you are understanding all these components as of now, just say yes in the chat window. Okay, so all these components, then say yes in the chat window so that we can go ahead. Yes, Rhythm, I'll be coming to that point, but no worries. So I think my laptop battery is connecting and disconnecting in the charging mode. Right? Fine. So very much. So you all are understanding it very well. So it's fine as of now, right? Likewise, we have kube scheduler, we have node controller, we have few more controllers here. So let's say those controllers I'll be talking about later on, but let me introduce one more. And the next component in Kubernetes master is replication controller. Replication controller. Okay, what is replication controller in reality? Replication controller is something in Kubernetes master that will make sure number of container availability in the worker node. That means this is the very important component. That means, let's say as an engineer you use Docker image to deploy 2 containers, and these containers are randomly distributed here and there by using kube scheduler. So let's say container 1 is running here, container 2 is running here. Now by any chance this manager or minion node 3 goes down. If the minion node 3 goes down, this container will be down. So what replication controller will do, because in the beginning time you decided to have 2 containers for this Docker image, so this replication controller will connect with kube scheduler and it will plan the container somewhere else in any of the minion node those are healthy. So that means it will connect to any of the minion node like this or this, and then it will check and use it. So simply this replication controller is responsible for maintaining the container count. So anytime if you have lack of containers or one container goes down, how the container will be created automatically. So you don't have to do that, it will create automatically. Okay, so automatic container creation will be happening in that case, right? So I think replication controller is also very much useful, and it must be understood to you as well that yes, you are understanding it well, the role of replication controller here. Okay, so yes, so this is the very important component where it will maintain the count of container, right? Yes, no, yes, no. So these are few components. So just say yes in the chat window. Okay. Please do remember all those things, because these are very important for tomorrow discussion. But as of now, we are having all this. Okay, wonderful. So 4 things are running. See, so by combining these names, let's say we have in master node we have API server, we have kube scheduler, we have a node controller, we have replication controller, right? So these components, they are running here. So by combining them in single entity, we are calling it control plane, right? Control plane. So that means these all are control plane component. So rather than calling them individually by their name, we can also call them, this Kubernetes master has components, and these components we call it control plane component. That means here we are going to call them control plane components, and these are running in the master node. Okay, so you can call them control plane component, or you can call them on the master node, or whatever you want, but control plane component is an official keyword by Kubernetes. Okay, so control plane component is very important thing. I think you can remember that. Okay, now so, but there is a problem. The problem is how Kubernetes master node will remember how many containers, how many applications, and how many nodes are running and down in the Kubernetes cluster. So that means how Kubernetes will remember the status of Kubernetes cluster or application. So what does that mean? Let's say we have one master, 3 minions or 2 minions. Out of 2 minion, this minion is almost full 50%. This minion is only 30% consumed, and this is only 10% got consumed. In minion 3 we have 10,000 containers running. In minion 1 we have these many containers running. Out of these many containers, how many are healthy and which website is up and down, and if one minion goes down, how it will be migrated to here. So that means whatever going on in the running Kubernetes cluster, this information needs to be stored persistently, right? Because if somebody is rebooting all the machines, all the information must be stored persistently. Okay, so in the Kubernetes master itself, there is a database server, and we call it HCD. So this is one of the most popular and powerful and fast database server, and where every single status of Kubernetes cluster, either cluster status or application status, let's say how many cluster we have, how many master and minion we have, which is healthy, not healthy, how much RAM, CPU, every single thing consumption and will be stored by etcd. So it's a pure NoSQL database that store data in a key value pair, right? And that etcd is also running on the master node. Okay, so the status of cluster or application will be stored in etcd database. So this is the next component in the master node. Okay, so and this is the most important component. I can see the brain of Kubernetes, because every memory, every information will be stored in etcd, right? So are you understanding the brain of Kubernetes cluster etcd? It's a pure NoSQL database like Redis, and it will store information in key value pair, so that whatever things are going on in the Kubernetes, it will be persistently stored here, right? If this is also very much cool for you, then say yes or okay or cool in the chat window, right? So waiting for your responses here. Okay, 1 2 3 go. So for Khushi, Chandrasekhar, Rhythm, Harsh, and many more in the pipeline list, and this is very much okay for you as of now. So simply, if this is very much understood, it's really very awesome for Kubernetes. Okay, yeah, it's very hot. Fine. Now one more thing, why I have not counted etcd in a control plane component. See, why we are not counting etcd in a control plane component? Because in some of the cases, if this is your Kubernetes master and this is 1 2 3 4 component: API server, node controller, kube scheduler, and replication controller, we are having etcd here, but this is optional. If you don't want to put it under master server, you can deploy a separate server outside your Kubernetes cluster, and you can deploy etcd here. Then you can ask your API server to read and write information from here. So whatever the status of cluster, whatever things you want to read and write there, you can put it over there. So that means every single thing, including cluster information, you can write here. And who will do the job? Kube API server. Yes, Boni. If Kubernetes master will go down, your application will be maintained. Cluster is a different thing. But we have such an architecture, so don't worry if the master is go down. I'll be answering to that question, because we can have multi-master in that case. Okay, fine. So etcd can be outside it, that's why we are not calling it we are calling it Kubernetes control plane component. Okay, now see, we have so many components running here. So you know what, for a Kubernetes administrator or engineer, it's really impossible to maintain and manage these many services one by one. So there is a service in Kubernetes master, we are calling it kubelet. What kubelet will do? Kubelet can maintain all those components alone. So that means it's a kind of daemon or service that is maintaining or troubleshooting and managing all these components for Kubernetes master. Even it is also responsible for connecting to another kubelet running anywhere else. Okay, so there's for that thing you have to wait for one or more session. You will get your answer automatically. So every components are individual, okay, and every component can connect to etcd, but how, that is the question, right? So etcd never going to connect anybody, all the components will come to etcd. By the way, this information will be maintained and managed by only API server. Right? Alright, so now kubelet is something that will managing this Kubernetes master entirely. Going back to this architecture again. Okay, now we have done with the Kubernetes master component. These are not all the components, actually there are so many, but at least these are the ones that you really need to understand. Okay, and these are the most important and most popular components of Kubernetes master. Going back to minion nodes, so we have minion 1, we have minion 2 and minion 3. Everywhere we have installed Docker engine, and the Docker engine is running smoothly. Okay, let's say if you remember that fact, whenever you install Docker engine for the first time in any of the machine or node, what else things are coming by default? So a bridge called Docker 0, another bridge called Docker 0, and same Docker 0. So if you install Docker for the first time, generally a bridge called Docker 0 will be coming to each and individual node, and because the bridge name is same for every Docker, every new instance, IP will be same. Okay, now say if you launch container 1 here, it will be getting IP from here, container 2 here getting IP from here, container 3 here getting IP from here, because we have so many, we have 1 to 3 million node, and so many containers can launch there, here and here, because Docker 0 is the only interface that is connecting in every system. So you know what, these containers can have almost same IP as these container or as these containers, because you know what, every time you install Docker in a new machine, they will get a fixed series IP address of this, of this, of this. So let's say 50 container are here, and 50 container are here, and 50 are here. Each 50 container can show the conflict of IP irrespective to the worker node. So that means in the minion node 1, node 2 and node 3, if you go and check, there is a lot of possibility of same IP assignment by Docker bridge, because Docker bridge is offering this IP, right? So definitely Kubernetes is not going to use Docker 0 bridge to give IP address to container, because if they have same IP, how they can communicate, right? If you are understanding this problem, that Kubernetes cannot use Docker networking like Docker bridge or something, so we need to think a solution for the same. Okay, so if you are understanding that fact, Kubernetes cannot use Docker networking across the minion node, because the IP can be conflict, and if the IP is conflicting, how container 1 from worker node 1 will communicate to container 2 to worker node 2. So we don't need container based networking or Docker networking in Kubernetes cluster. If you understood the point, Say yes in the chat window, and if you don't, I can repeat it again, hoping for your responses. Alright, so make sure you are understanding it very well. Right? Great. Anyway, fine. So if you're not going to use Docker networking, then what we'll do, will not use Docker networking. We will create a common bridge, one bridge, let's say called Ashutoshh bridge. Okay, and the same bridge will be connecting to this Docker engine, and the same bridge will be connecting to this Docker engine. Sorry, and the same bridge is connecting to this Docker engine. Now, rather than having individual Docker bridge in every single system, we'll have a common bridge across the worker node. So that means we'll create one virtual bridge that will be connected to each and every Docker engine. So even if you create container here, it will take IP from here. If you create container here, it will take IP from here. If you do create here, it will take IP from here. So this single bridge will be responsible for giving networking solution to all the containers across the minion or worker node. Even master node will also be connected to, so because Docker engine is running in the master node as well, so your master node will also use the same bridge to connect. Okay, now who will create that bridge or such a bridge that has connectivity with all the Docker engine in the Kubernetes cluster? So there are so many open source networking solutions like Flannel, like Calico, like Callium, right, like WaveNet, and so many. So any of the networking, or we have Cisco ACI. So we have so many networking projects. You can use any project to create this bridge. Any one, right? Not all. You can use any one. We are going to use Calico for the bridge as of now. There are so many reasons behind that. So Harshvardhan is yes, Harshvardhan. So the concept will be same for other container orchestration tools, but networking plugins will be different. Yes. So even this will be same, but networking plugin will be different. Right? So about this, right, if you understood it very well, then it's okay, we can talk about the same. Right? Say yes in the chat window. Right? Okay, so we are going to use Calico, right? Now one final component, because there are so many, make sure you are not getting confused in one way or another, right? So just keep that patience. All right, now the final thing, see, so what final thing is going to happen? This will be my Kubernetes master, here will be my minions, they all are connected to each other like this, and the most demanding component in Kubernetes is Kube API server, and a developer or user can connect to this, then it can pass to Kube scheduler. Kube scheduler will find the right node and deploy container here. These containers will get networking from a common bridge technology, and here we'll be using Calico. Okay, in some cases you can also schedule container here. I'm not saying you cannot, it's possible, but by default Kubernetes does not schedule any container in Kubernetes master node. See, so now let's say if the container 1 is here, container 2 is here, container 3 is here. Okay, now I want container 3 can communicate to container 1, container 1 can communicate to container 2, but container 2 cannot communicate to container 3. Okay, so who will maintain this communication of containers across the node? It doesn't matter either they are in the master or in the minion node, but I want the control in communication in the containers. So a component running everywhere in Kubernetes cluster, and that is Kube proxy. Kube proxy will maintain the communication between container across the worker node, right? It will maintain the communication between container across the worker node, like worker node 1, 2 or 3, like this. Okay, so here it will be running, and because in the worker node also the component kubelet will be running, because kubelet is responsible for connecting to master node that I'm healthy or not. Okay, so kubelet is like a main component of this that can maintain the, yes, I need to report it back to master, and kubelet has also this functionality. So I hope kubelet, just ignore it for now, but you are understanding this kubelet, sorry, kube proxy. If kube proxy is understood, finally you can say yes, and we are done with the component of Kubernetes as of now, as per the requirement, right? There's so many things, but okay, it's all right as of now. And now we are going to talk about installation of Kubernetes cluster. Okay, installation of Kubernetes cluster as of now. Okay, so what I'll do is, let's have a tea break, because it will take time of 10 minutes only. I need to do something, preparing some tea or something. 10 minutes. It's around at 12:30. So 12:40 will be back. Exact 10 minutes. Okay, I'm stopping this streaming as of now, right? We'll continue. Yes. Okay. Hi. Hello. Message. Uh, in the chat window. You can hear me now, and you are back again. Type back or hello message in the chat window. So Rhythm is here, Kushi, Chinmay. Most recent version of Kubernetes, Tej. So I can see 11 people. Where others gone? Okay, only 11, 12. Right, so my concurrent correct connection where is showing. Okay, 21. Fine. So we are now starting with the Kubernetes installation methods. Okay, you know what, there is a lot of complexity in the installation methods, but we have to learn the way where we can use Kubernetes to understand it well, right? That means, let me tell you. So the installation of Kubernetes will be something like is divided into a lot of categories. So type of installation, right? Type of installation and how we are going to do that. So Kubernetes installation can be installed in a very different way. The first, and this method will be used by all of you because you have lack of resources. So the first one is single node Kubernetes cluster. So when I say single node Kubernetes cluster, that means you will be having only one physical server where your master, your minion, both will be running in a same machine. This is for just testing purpose. So for example, you are a student now and you don't have that much big enough or big server. So for testing and for practicing, you can use single minion master server. So one single machine will be working as a master and minion, and all the components of master and minion will be running here only. So any testing engineer or developer or student, right, they can use this first kind of Kubernetes cluster. Okay, now the second is multi-node KTS cluster. And when I say multi-node is also divided into two categories, where we can have one master and we can have n number of minions, right? And where we can have multi-master and we can have n number of minions. Okay, so single node cluster, multi-node cluster. Multi-node has two categories: single master multi-minions and multi-master multi-minions. And this setup is very popular, and this setup is using by most of the companies as of now. And you can install this setup anywhere. You can install in VMs, you can install in laptop, PCs, or in cloud environment, anywhere. So there is no a platform dependency for doing this setup. So if you have 2 PCs, 3 PCs, so many VMs, you can install this thing, either this or that. So for production we are using that one, for pre-production environment testing we are using that one. So anyway, so this is the second method. Now the third and the most popular these days is Kubernetes as a service. Kubernetes as a service. So we have so many cloud provider, they are giving Kubernetes as a service. When I say Kubernetes as a service, so that means there are so many cloud provider like Amazon, like Google, like Azure. So we have so many cloud provider, like we have AWS, we have Google Cloud, we have Microsoft Azure. These days we have Oracle Cloud as well. We have VMware Cloud. These are all cloud providers. We have Alibaba. Okay, many cloud providers we have. So if you don't want to install cluster in this way or in that way, then you can use Kubernetes as a service in a cloud environment. So that means, like in AWS, we don't have to install VM, we can use EC2 to launch a virtual machine. Likewise, for deploying Kubernetes cluster, we have a service called EKS. So this is cloud managed Kubernetes service for any production company. So I can show you by login in my Amazon cloud, right? So I'm just log in here. And I hope, oh my god, my username, password. Right, yes, so I'm logged in here, and if I go to services, right, then I can search for EKS, Elastic Kubernetes Service, and this is the most trusted and amazing way of deploying Kubernetes services here. See, it's a fully managed Kubernetes control plane, right? So the service name is Elastic Kubernetes Services. It's very easy to deploy, right? I'm really not going to talk about this anyway, but this is the very good option for the one who really don't want to fall in the complexity of deploying Kubernetes cluster. Okay, but this is not free, it's very high maintenance Kubernetes cluster. So if you have good company or you have big management servers, you can use EKS. If you are using Google Cloud, you can have GKE, that is Google Kubernetes Engine. For Azure, you can have AKS. Oracle has OKE, Oracle Kubernetes Engine, and many more. So EKS, GKE, AKS, these are the different cloud provider services. So Google Kubernetes Engine, Azure Kubernetes Services, Oracle Kubernetes Engine, like VMware Kubernetes Engine, Alibaba Kubernetes Engine, and so many things are there. So we are not going to use that, and I'm even not going to tell you how we are going to deploy this, because this is really out of scope. But yes, we have this way. So now a normal company or a student can use this version, or a big companies can use this version. Okay, so you know what, I'm going to tell you the installation of first one only, in case you are really curious and you want to learn one master n minions number of machine, then I'll be telling you. But you know what, you are a student and you don't have such 4 machines, let's say 1 master and 3 minions. So 4 VM 4 machines management is a really tough job for Kubernetes, but installation you can just try it, okay? But as a student you can use this method, okay? You can use this method. So in this entire training setup you need to use, just to learn, not in real world, single node Kubernetes cluster, Kubernetes cluster. So this will be something like this. We'll have one OS, and in this OS your master, your minion, your etcd, and all the components that we have discussed till now will be running here. So you can use from there simply, okay? So that's why we are calling it single node. We have only one OS, one laptop, one virtual machine, something like this, okay? We will be using that. But before using that, let me tell you how we are going to install one master and 3 or 2 minions cluster. You know what, sometimes I feel like I'm Bhagwan, right? So I'm just giving you a link, 1 master 3 minions, and installation is done, okay? So how you can find the method installation is done, just go to my YouTube channel, youtube.com/C Ashutoshh Singh, and here you can just check on videos, and in the videos section if you go down a bit, right, so in the very deep in the cloud somewhere, where is my Kubernetes? So I'm unable to figure it out. Yes, this is where you can exactly follow step-by-step process. Yes, so this is your Kubernetes cluster installation in Amazon cloud, and I'm sharing this link on the chat window. See how fast I am. It's just, so you can assume that we have this one. So you can watch this video, and it's a very step-by-step installing cluster in Amazon cloud by using one master and number of minions. If you want a documented version of it, so what you can do, you can just go in Google and type my GitHub username, right? So this is my GitHub username. Just go to repository, and in the repository you can search for repo K8s. You get this link, repo, and here very much step-by-step installation is written. Kubernetes, the production grade container orchestration tool. So everything is written like this, and we have 4 machines, 1 master, 3 worker, and you can follow step-by-step process here, okay? If you want another resource, we have /DevOps blog, alright, and in /DevOps blog you can type Kubernetes here, and you'll be getting this first blog. This method is very old. I have written this in 2017, and so everything is written, and this is also a good method, but this is very complex approach actually, so you don't have to follow that. but yes, this method you can just check for your information and knowledge. Okay, so this GitHub, this blog, and that what I say is something. Okay, so I hope you can go with that and you can install it in your own way. But what I'm going to show you this method, single node cluster. Now how you install single node cluster? So single node K8s cluster. So that is, there is a software, we call it Minikube. Okay, there is a software, we call it Minikube, and this software you can install in any operating system. So let's say by using Minikube we can install single node Kubernetes cluster. So I'm gonna search Minikube install. Okay, just open the first official website. If you want to learn anything about Kubernetes, the only place is kubernetes.io here, and they have given the method to install Minikube in Linux, Mac and Windows. Okay, so without even worrying about anything, you can choose your tab. If you are a Linux engineer, just first check this, then what you have to do, you have to install this, then you have to install Minikube here likewise. Okay, and if you are a Windows engineer, so Windows guy, you can just download this Minikube installer for the first time, exe file, and install it simply. Once you install Minikube, then how Minikube is going to install cluster automatically? So here Minikube is an automated way of installing single node Kubernetes cluster. So now Minikube is really very popular these days for developers, okay, or for students also. So you know what Minikube will do? Minikube can use your any of the virtual machine product. It can use your VMware, your VirtualBox, or your KVM or Hyper-V. So I'm expecting that you guys are having any of the virtual machine software. Okay, so if you have, everybody is having, right? Just tell me the name of software that you have in your current laptop in the chat window, so that I can tell you the method how we can use Minikube to install your Kubernetes cluster. Just type comment in the chat window which software you have, VMware, VirtualBox, KVM or Hyper-V. So VMware, VirtualBox, VirtualBox. Okay, so any of the software you are having, use whatever you have, it doesn't matter. So the most of the choices are for this. Okay, choices for this. So once you install Minikube, right, what do you have to do? So let's say if I have installed Minikube, so for Linux and Windows, right? So let's say I'm just using Linux tab, and I'll install this Minikube. I'll download it. So I'm opening my terminal. let me download it. Right, may take some time. Yes, it got downloaded, Minikube. Then what you have to do, you have to move this file Minikube under USR bin. Okay, like this. I moved it. Then you have to give executable permission to Minikube. That's it. So this is the very simple installation step of Minikube in Linux. And if you have Windows machine, you have to follow the same way. What you have to do, just click on the Windows tab here and then download this exe file, Minikube installer. Once you download this exe file, just install it. You don't have to set any path or anything. So in Windows it's very easy. Install it, and now Minikube is available in your terminal and CMD and PowerShell. Okay, so you don't have to worry about anything at all in Windows as well. Once you got installed Minikube, so what you can do, you can use, let's say I think I have VMware, or I don't have I think. So let me install VMware, sorry, VirtualBox. I have VirtualBox. So yes, VirtualBox is already here. So if the VirtualBox is here, now how to install Kubernetes cluster, it's very easy. So let me tell you here. Once you have this Minikube installation, so I'm just searching Minikube start VM driver. So you have to do Minikube start -VM -driver is equals to VirtualBox. Okay, if you do this, if you have VirtualBox, so okay, my Minikube is already there. Once you do that, what it will be doing, because I already have this and it is saying delete the cluster first, then start it. So what I can do, if you do this command, right, it will take around 25 to 30 minutes depending on your internet speed, and your Kubernetes cluster is ready. That's it. Likewise, you can have VMware. So you can search what exactly is the name of driver here, -VM driver, and this. So what it will be doing, actually it will install a virtual OS in your VMware or VirtualBox. Then it will install Docker here, then it will install Kubernetes, and everything is ready, up to ready. You don't have to worry anything. So are you understanding it? Right? Same in Ubuntu also, same in Windows also. So after installation of Minikube, you just have to do this and change your driver name here according to the, you can Google it, what exactly the name you have to write. Are you understanding it? Say yes or no in the chat window. Alright, so it will take 25 to 30 minutes. It will install the entire OS, then Docker, then Kubernetes. You don't have to do anything at all. So it's very easy method. Why it is complicated to understand rhythm? Installation method or Kubernetes? Okay, so we are just talking about the installation of Kubernetes cluster. using Minikube. So you can assume Minikube is an automated installation method, automated installer of Kubernetes. Okay, if it is very much complex, and let's say for those garib people who don't have enough RAM or CPU in the OS, so your VMware VirtualBox will be hanged. You know what, the most exciting news for the ones who don't have VMware VirtualBox KVM, but if you have Docker already running, right, if you have Docker already running and you don't have any of this, if you have Docker running, Minikube also can use Docker, right, can use Docker, and then it can create a container, and this container, inside this it will create another container and it will install Minikube cluster Kubernetes here. See, Minikube can connect to Docker, Docker can create container, and this container can create another container, and here your Kubernetes will be running. So if you don't want to use this setup these days, you can use this. So what you have to do is, here you can see here in the Minikube you can also use -- driver is Docker. So Minikube start -- driver is equals to Docker. Fine. If you do this, it will take one Docker image automatically, and it will create a container first. It will pull a new Docker image from Google. It will prepare everything for you. Just wait for 5 to 10 minutes max. It will make the cluster ready for you. Look at the emoticons. I really love it. Done. Yes. Voila. I mean, seriously, Kubernetes cluster is up and running. You can see here by Docker PS. See, this is running. So you know what? This is a container, and under this another container is running. See, so we are using Docker. So what Minikube did, it created a container. Under this container another container got created where your Kubernetes is running. See, so if I'll do docker exec it minikube bash, so it had installed Ubuntu 19 point this, and if I do docker ps, there are so many containers running here, and these are, see, API server, controller, etcd, kube scheduler, Minikube system manager, and kube system, and so many things are running here. So isn't it cool? Very much, right? See, so the thing is, by using Minikube we started Docker driver. So then it launch a container, and in this container, if I'll do it like that, ECIT minikube bash, in this container we have OS, and that has another so many containers are running. Now you can understand that plan, why I have given you that task, the Ansible task, so that you can understand that methodology, and this is really love. Okay, so you know what, you can understand the complexity now. Kubernetes is to create and manage container. So Kubernetes got installed by Minikube. Minikube using Docker. Docker created container. Container created so many containers to maintain the Kubernetes product, and these containers will manage those containers that will be created by this Docker. So if you're understanding it very well, say yes in the chat window, right? And really congratulations, I mean बधाई हो, आपने Kubernetes cluster install कर दिया, right? So फटाफट just give big hands and yes, okay, hurrah, boom. So installation is done. Rest, let's see, we have session maybe tomorrow. I'll let you know accordingly the timing, but you are understanding it. So I think you can use that one. It will be really great. You don't have to spend a lot of RAM CPU, because if I can show you how much resources exactly consuming my Kubernetes cluster Minikube, so it is consuming only 1.3 GB RAM. See, this container is consuming 1.3 GB RAM, 15%, 20% core CPU, and a bandwidth. Fine. So see, entire Kubernetes under single container. I really want to write this. All K8s is under a single container. Now these container having so many containers, 1, 2, 3 and 4 and so on, right? Anyway, so just enjoy the mahal, and Piyush and Harsh, you make a list of the email address along with the names, and it must be a comma separated file. Send it to me. I'll make this video, I'll make the streaming link from tomorrow private, and you have to log in from your that account, that Gmail ID to your YouTube channel. Okay. So this Kubernetes cluster installation and discussion is done. I hope you enjoyed. So thank you so much, guys. We'll see you, right? And have fun. Okay. Nice. All right. So now I'm terminating, stopping this streaming link. If you have something to ask, please do. Rest, we can just wrap it up, this session. Okay. Wonderful, guys. So thank you so much. Bye bye, and wait for the next exam very soon. My motive is to just to prepare for you guys for, you know, next Kubernetes conference that is happening in Bangalore, and you can go to, you know, there. All right. Wonderful, and have fun. Bye bye.